These are the Nirenberg and Mattei and Nirenberg and Leder experiments. The Nirenberg and Mattei poly-U experiment was performed by creating an environment of ruptured E. coli. This created a system that would be able to produce amino acids when given the correct mRNA strand. The next step was to isolate all of the amino acids into their own test tube. For each round of the experiment, one test tube would be radioactively charged while the others would remain stable. Next, a strand of mRNA was translated, whichever one would like to be tested with the E. coli. This created a precipitated protein, which was placed in all of the free amino acids. Finally, the radioactive amino acid was checked for radioactivity after the complex formed. This here is a graphic to explain the poly-U experiment. There's an E. coli sample in which the RNA insertion creates a protein which then would be inserted into the amino acid and then determined for radioactivity. The most famous experiment was done with the poly-U chain, which created a protein that when inserted into phenylalanine would become radioactive. Since the poly-U chain remained radioactive with the amino acid phenylalanine, it can be concluded that the phenylalanine was created with the UUU codon. This later found that the AAA codon would code for lysine and the CCC codon would make proline. The GGG codon, however, would not form a radioactive amino acid. The Nirenberg and Leder triple binding assay procedure was done by taking a short length of nucleotides that could be individually identified in order. They were then mixed in a solution with tRNA and ribosomes. Next, an amino acid was added with a radioactive charge. Then the solution was passed through a filter that would filter out unbound amino acids, and the final creation would be checked on the filter to determine whether or not it was radioactive. This here is a graphic that shows the ribosome complex, the codon, the tRNA, which went through a filtration system, and then the final solution, which had a radioactive, potentially radioactive filter. The results of this triple binding assay was that previously the components of the codon could be known, but not the ordering. For instance, an amino acid with 2 G's and 1 C could be GGC, GCG, or CGG. Using this method to identify the components and ordering of the codons, 61 of the 64 different codons were actually identified correctly, based on their order and not just their components.